Okay, so this is the kit for the Electrohub, and I'm gonna unbox it. Oh, sorry, set. See what we have. All right, we got everything in this one. So we have booms, we have motor mounts, we have Electrohub, hopefully motor mounts. And then this one, this is the camera tray, which will hold the Mobius. So that's way at the end. I'll put that off to the side. I don't need this. Junk pile. So then we have the electronics kit from Ready to Fly Quads, and that is 4 motors. 2 propellers here, 2 propellers there. Not sure if I'm going to use them. This is a multi-wheel flip flight controller. Not going to use this. We're going to do the Naza. This is the Lemon RX receiver. It's got stability. I don't want that, but I'll turn that off. And it's got a satellite, which is cool because we may be able to plug. Actually, we may just be able to plug the satellite into the Naza and see if that works. I don't know if it has the input for it or not. Probably not. Either way, if it doesn't, then we will just use. Actually, let's use the Spectrum instead. So this is a spare part. Spectrum has telemetry, which tells me voltage, which is great. So here are 4 ESCs, random wiring. Looks like, I'm not sure what that is. Maybe servo connectors. And here is our XT60 battery connector. We'll need that. So let's lay this all aside. We don't need any of this yet. These are, by the way, 90 kVs. About the same that comes on the DJI. So now I'm going to have to watch the video, and then once I'm to a step, I will do it. Film. I will perform a step, film with the GoPro. Okay, so this is the Electrohub, and to do the dead cat configuration, you want to find, this is the center line according to flight test. You want to, your booms are going to go one to the right and one to the left for the front booms. Okay, so this one will be your front hole in your front left boom. This will be your rear hole. So what you do is you find the center line. Find the center line. Just go down the width of a boom and eyeball the center, make your cross, take a straight edge and draw down. Okay, and then once you put this together, you go ahead and line up the first cross you made. So we know that this is what we're looking for here, and that's what we're looking for. So once I had them lined up, I eyeballed them and made sure they were correct, and then I put a cross here to tell me what was going on there with the holes. So now I know where to drill. There. I'm not exactly sure what size drill I should use, so I'm going to go eyeball it with the drill bit. Okay, so I had to watch the video. Kind of a pain in the butt, but it's hard to explain. Once you have your center line, you're going to go 1 to the left. This is the center line. 1 to the left and 2 to the left of the hole. So the front screw goes here, back screw goes there. Same thing on the other side. 1 to the right, 2 to the right of the hole. Front screw, back screw. So then you can line this up and look and see what you got. So I'm going to go 1 to the right, which would be here. 2 to the right of the hole. So I've got that marked. So now I know where to cut my holes, and I'm going to go ahead and do that. And then once you have one done, you can do the other one. So now we can test fit. See if it lined up. If not, we're screwed. We start over on the other side. So let's see. One to the right. And two to the right of the hole. That lines up. Now, if you really want to be tricky about it, the easy way to do this is to, well, these aren't the exact same length, so that'll be interesting, but they need to be the same length on this side. So if you want to get crazy with it, you can do it this way. And just drill through. I'm not sure I want to do that. Don't trust it very much, but we'll give it a shot. That one. Line up again to make sure. We got two holes. Let's test fit all of this. Okay, so this one. One to the left. Perfect. Two to the right of the hole. That's going to work. One to the right. Two to the right of the hole. That's going to be a little tricky. Yeah, I think we can get it though. Yep, they line up. So that is the front, and the reason it's so spread out is because it's a dead cat, which means you have no props in view of the camera. So let me figure out how to do the rears, and then I'll move on from there. Okay, so let me get this out of the way. This is the way it's supposed to look. Two away from the right-hand side hole, straight down. Two away from the left-hand side hole, straight down. And then once you get your fronts in there, it'll be more of a swept angle in the front because it goes from here to here and from there to there. So that's what keeps you from having your camera in the frame. I'm sorry, your props in the frame. And all I did was the same method I used before. This is a little bit off, but I drew, this is the second one I did. First one I did, this is the width of the actual boom itself, like that. So you draw across that way, and then a straight line across, and that's, you can see I had to center that a little bit more, but a vertical line there, about halfway in between this line and the edge. And then once you have it set up, you put the screw through it, and then you find the hole and you mark, and then you drill. And then for this one, I just set the first one on top of it, made sure it was lined up perfectly, and drilled all the way through. And so that way I've got two that are identical. And you can see they're a little bit weird. This one's a bit weird, I'm not sure why. But it works, and it's going to be strong, so it's not going to be an issue. Okay, so I was actually showing using the top plate to do the drilling, but it doesn't matter because it works out the same way in the bottom plate. That makes a lot of sense because how else would it work? So this is the way it goes. This is the front, this is the back, this is the dead cat configuration. I went ahead and test fit all the screws here, and they all fit fine, so my drilling was correct, and that's the way it's going to look. So you are two away from the hole here, two away from the hole here, one to the right of the center line to two away from the hole, one to the right of the center line to two away from the hole. That's how you get your dead cat. Like that. So it works. Next step is to follow along some more and try to figure out what else we need to do here. And that's planning where the ESCs go, how long the wire lengths need to be, and then soldering the ESCs into this board here. So that's something that I'm going to need to do next. They will go actually underneath. If you see underneath, there's the big pads and the little pads. ESCs go underneath because this is the top, this is the bottom. Okay, so ESCs are going to solder to these pads, and I'll see if I'm doing it right by watching. So now all this is tightened down. It's a pain in the butt. It's metric. The screw they gave me is metric. I didn't have a socket, small socket in that was metric, so pliers, driver. Try not to scar any of the traces, or else you'll be in big trouble. So next thing to do is to gauge if we have enough, we need to gauge our ESC placement. And as I mentioned, positive, negative. On an ESC, generally it goes like this on the bottom. This is a control to your Flite controller. Okay. These 3 wires go to the motor. The connection of these 3 wires, in whatever order they are, can be it can be anything on the motor, but the way they're connected determines the rotation of the motor, clockwise or counterclockwise. So if it's not right, you switch one with another one. If you change any 2, it'll change the direction of the motor. So next thing is to figure out the placement of these guys. Obviously we're going to be doing positive and negative, something like that, right? And soldering onto those pads, zip tying them up here, and then we have to figure out motor rotation and make sure it's correct. And we're going to heat shrink wrap this also. That just means using a heat gun to shrink that up. Okay, so the next thing I need to do, what we're going to do is actually remove the solder here. And once we remove that, we're going to cut these to length off the motor. And then we're going to go ahead and solder here and check motor direction with a servo tester. We need 2 clockwise, 2 counterclockwise, so I'll get to doing that right now. One more thing we need to do in the motor kit, this post needs to fit to this propeller connector adapter. So you've got to line up these 4 screw holes with the 4 screw holes here. So once you do that, it's a little bit difficult, but I think I nailed it on that one. A little bit that way. Then you're going to want to put sink in these screws, and you're going to use blue Loctite on them. So I believe I've got a little bit here. That one's not open. If you don't use blue Loctite, there's a decent chance that you'll be flying along and you will lose a prop, and that is not good. Always use Loctite. These should be fairly tight because you do not want to lose them. My shaky hands are not good for these little things, but I just get through it. Okay, so there's one done, and these other pieces we set aside because we may use them, we may not, probably so. But this is your top part for your motor, or for your propeller. So you would put your propeller on and snug it up this way, and that actually snugs down tight, so you can Loctite this as well. I don't generally do that, I just check them every flight. So we're going to do this to every motor as a prep piece. We'll keep all of our extra pieces in here. These are mounts to mount the motor to the frame. These are adapter plates, so every one of these motors needs to be set up exactly that way. We've got to do it that way because we can't check rotation without having this post on here to put a piece of tape on to check rotation once we use our servo tester. Okay, so every motor has the actual shaft on it and Loctite and little screws. Some are a little tough to get on, some were easy to get on. I'm not sure if that's going to affect the balance or not, but that's why you balance your props. So this next step will be to remove the solder from these 3 joints on each of these ESCs. So what we're going to do is take the heat shrink off, place it away. We're going to reuse it and prep all these for removing, and then we'll, if I can find my servo tester, we will go ahead and try to test rotation. Because in any quadcopter, you need 2 clockwise, 2 counterclockwise. Generally, it's like this and like that to counteract rotation. So we'll have to see how it works. But I got to get busy doing this part. So these need to be not messed with too much because they're a little bit fragile. But I'm going to get the servo tester and the rest of the stuff and get going on that. Okay, found the servo tester. Essentially what you do is you put in 4 to 6 volts here, okay, and you output servo leads here. Servo leads are a little bit different. Let's see here. Trying to figure out what to show you. This is a servo lead. It's 3 wires generally. Plugs in there. Okay, so I got to figure out how I'm going to rig this up. But I'm going to have to get this guy going here. I'm not sure exactly how I'm going to do it. Anyway, I'll have to watch the video some more on Flite Test to figure out exactly how I'm going to do this. Alright, so I cheated a little bit. Got my servo tester. I've got a 2S LiPo, which is 7.4 volts. Probably not 7.4 right now. So this will go up to 6. Went ahead and kind of standardized what I'm doing here. So there's a right, left, and a center wire on here. Right, left, center. Right, left, center. In other words, black, blue, and red. And that way I can tell my rotation. So all I need is a piece of tape, and then I can tell my rotation if I can find some tape. I don't know where my painter's tape went. Duct tape will do. What you want to do that. Connect up your servo wire. And signal is always white. Positive is in the middle. And black is ground. This side is signal on the servo tester. So we're going to hook up this way. Okay. Then we're going to hook up negative, positive here. Negative is black. So now we've seen that the ESC has initialized. Let's keep these wires from touching, that would be bad. So we've got nothing here. That looks like it's counterclockwise. You see why you need to hold it. It will fly all over the place. Okay, so that's going that way. That's counterclockwise in this setup. Okay, So if we have a motor like this, this is counterclockwise. So I'm going to write on this, if I can find a pen, CCW. Now the way you're going to change it, if you've got 3 that are CCW and you want to change it, you need to change 2 of these wires. So in this case, that's CCW. Pull that off. We're going to pull the power because we don't want to burn anything up. Okay, I wrote CCW on that. See if it sticks. Hard to see, but if you look real close you can see it. And it sticks. So now what we got to do is take these joints off, take these joints off, cut this to length, and we know we've got 1 CCW, set that aside, that's in the CCW pile, obviously because it's marked here. Alright, so more to come. Some flight controllers are different. This is a Naza V2 we're going to use. So you can see it tells you which boom has which counterclockwise and clockwise. Counterclockwise, clockwise, clockwise, counterclockwise. That's to eliminate rotation when it's in flight. So there you go. So I know that this boom here is going to be counterclockwise. This one's going to be clockwise. This one's going to be clockwise. This one's going to be counterclockwise. So that's how I'm going to set it up. Okay. So where we're at now is we have made our joint. Make sure you don't get cold solder joints. Pull on them nice and make sure they're nice and snug, and they're not cold solder joints. They should be shiny. If your joints are not shiny, they're cold and it will break. So now we're going to heat shrink this. So what we've done is we have said to ourselves, we've got the right length. I gave myself a little bit extra just in case. Measured it from the end of the boom to where these 2 wires are going to connect up to power. This is your control wire. That's how I tested it. Now you need to heat shrink this so that it's protected. So we'll just pull out our heat shrink gun here. And I usually use the medium setting because I don't want to burn anything up. Sometimes it takes longer, so what? It will start shrinking when it gets cold, when it gets hot enough. There it goes. So you don't want to get too crazy with it or else you will wreck it. The side needs more. Watch your hands because it's hot. Don't hold in one spot or else you'll have a problem. So really what you're trying to do here is also to keep that heat sink on there because it will come off. And I can see I've got mine a little bit offset, but I don't think that's going to be a problem. Now you have heat shrink. That's pretty solid. That's not going anywhere. So this is my first counterclockwise, and on here somewhere it says CCW. So that's going up here. I know I've got 1 CCW. I'm good to go. So I do the next. Use the same process on this one. Save these wires because for some reason I always need this type of wire. We're going to grab another ESC. And I'm going to do the same, I'm going to use the same process. It's tedious, no doubt, soldering all this stuff together just for testing. But I don't want to mess with these pads until I know what's going on. Because that's close to things that are important, like the circuit board and the heat sink. So get this part figured out first, in what order these need to be in. Then desolder these and solder up in the same order you had them soldered to these wires before. Okay, so just an example of what I'm doing here. This is a clockwise motor. The rest of them I've done so far have been counterclockwise. Had to flip. These wires come out of these motors in a right, middle, left configuration. To get it to go clockwise, I had to put the right wire here, middle wire here, and left wire there. So this is desoldered. These are cut to length, and now I'm going to tin these wires and connect them up to the ESC. So that's tinned. Let's see. This might be slow and boring, but you have to tin your wires. If you don't tin them, they will not get a good bond. Okay. And this one I didn't tin yet. My iron is dirty, so it's not going to work very well. Don't scrape your iron too hard because it will deform. Mine's getting to that point. Probably needs some new tips pretty soon. So now that we've got that set up, let's get rid of our helping hands, which you should have. If you're going to do anything like this, you've got to have a set of helping hands. Another person does not count. So this guy is the right wire. This guy's the middle wire. This guy's the left wire, the way I look at them. So what happens is, I'm going to start with the middle wire because I know it has to go to the right side, and I'm going to go right to left when I put these on here. So these are pre-tinned. There's already solder on the pad. And my iron's getting kind of bad now. I don't like that all that much, so I'm going to add a little bit. And it fell off. So try again. That's what happens when your tip of your iron gets dirty or it's not in very good shape. That's a good joint. Okay? So that's the middle one. Now we're going to, I'm sorry, the middle wire to the rightmost pad on the ESC. That's a good joint. Got to have a good iron. If you don't have a good iron, things go badly. Okay. And this iron was 70 bucks. Don't go buy a $20 iron. You will screw yourself. It's no fun soldering with bad iron. It won't work on small stuff like this because the longer you hold it on here, the more likely you are to burn a component. If you burn a component, you got to buy a new one. So here's what happens. Middle wire, right side. Left wire, what I call the left wire, middle. Right wire, this side. So now we can test it. So where's my little test flag I got going here? Anyway, we'll make a new one. So we're going to do this to determine the direction of rotation. It's pretty obvious when you see it. This is a servo tester, Hobby King or eBay or something. I don't remember. So we'll go with our connection here. Turn your servo tester all the way down because you don't want to actually, if you turn it all the way up when you start it, the servo or the ESC will try to calibrate itself. You don't want to do that. You hear the little noise. You kind of need to hold this because this rotates around the bottom barrel. So as you can see, it's still going clockwise. Okay. So I've got two counterclockwise, one clockwise right now. Otherwise, it would be hitting the other side of my finger if it were going counterclockwise. Good to go. Pull your servo connector, pull your power, pull off your flag, throw your flag away because they always break on me. Now, next thing I need to do, I already marked it clockwise. It says clockwise, so I know which one's which. So now we're going to put our heat shrink back on, which we already pulled off prior just to make these connections. And these are, I don't know if they're cheap or not, ESCs, but they don't look like they're that great. But they're pre-flashed with Simon K firmware, which is the, kind of the firmware to use. It's got some features. You can look it up on the internet if you want to know what they are. So at this point, Get our heat gun hot. Try not to burn up our tablet or our hands. That's hot. Yeah, I think that's good enough. One of the reasons you want to heat this up and heat shrink it is to keep that heat sink on there. So I know this is a mess, but I've got 2 counterclockwise laying around already, and 1 clockwise, and then I need to do 1 more. So when I'm done with that, I'll move on. Okay, so we have motors mounted, and per the diagram, I didn't show you how to do the discs, but basically you can see you run 2 screws up through a bottom disc and attached to a top disc, goes through a top disc and into the bottom of the motor. You need to Loctite these screws or else they will come loose and you will lose your quad. Well, it'll crash. Same thing. I oriented the wires to the right side of each one of these motors so that I could place my ESC like this. There'll be some slack because I left myself slack on purpose. I'll just tie that up with a zip tie. So we've got 4 motors connected to the plate, or to the booms, and the booms to the plate. As it says, I marked them so I know what's what. Counterclockwise, clockwise, counterclockwise, clockwise. And I will actually test this again with 4 different flags on each motor. You don't put propellers on until you're absolutely certain everything's working the way it's supposed to go, or you will cut your legs off. It sucks. So now I'm going to mount up and position the ESCs where they should go. I've got a lot of extra, probably more than I anticipated, but it's better to have extra than it is to have wires too short, because then you have to make a solder joint and that can fail. You know, the next thing we're going to end up doing is finishing up this wiring here. Then we're going to figure out what we need to mount where for a top plate. So the Naza, there's a top plate that goes on here. I'm not exactly sure how it goes on, but I'll figure it out. And it may have to go, these may have to be removed and the top plate put on. No big deal. I'm not sure yet. Either way. So what you have here are a bunch of Velcro holes, or I'm sorry, zip tie holes. You can put your flight controller up here, and then you hang the rest of your crap off. So all this stuff, with the transmitter and everything like that, that's all going on this top plate or on a boom. The Mobius will be on a camera tray out here, and it'll be connected to a 600 milliwatt transmitter that will be feeding me video from the Mobius. So not, you know, 3 hours away maybe, but I'll keep going and I'll show you what it looks like when I'm done with this part. I have to solder this all up. So here's an example of how I do it. Joints connected to the power distribution board. This is actually the front this way. ESCs zip tied to the arm. And that's what I'll continue to do the rest of the way around and see how it looks in the end. Okay, finally done. ESCs are tightened up. I'm not sure if I'm going to leave them out like this or if I'm going to tighten it even more. There's circuits on the back of these that I don't want to mess with. I may move them down to here so I've got a way for it to sit, but I don't want to put pressure on that joint, that solder joint, so I'm not sure what I'm going to do here. I may tighten these down or find another method, but there's a close-up of my soldering job. I'm no expert, but I know when I get a good joint and when I don't. So next step is to do the top plate and connect up connect up my battery connector, which is this. That's got to go into 2 of these, positive and negatives. Same way, I'm not sure which way it's going to go. Probably back here in the back. I don't know. We'll see what it says. So moving on. Okay, I got a lesson for you. Make sure your solder joints are not touching. because when I plugged in the battery the first time, checked my video transmitter connected to the Mobius, and it works, of course. Two of these pads were touching and got a spark, and you definitely don't want a spark. So I immediately recognized what was going on, took a look at all these pads, and one of them had flowed into the other one. The main battery pad had flown into the positive fluid, had flown into the negative. So don't screw up. Battery, it's a junk battery I was using. I'm not worried about it. So it'll be fine. Another issue, you need to connect up all of your accessories before you put the top plate on, or else you got to take it back off and do it over. So this PDU, power distribution unit, has a lot of little positive and negative solder pads, and I left 4 big ones available, or 3 big ones, because I had to take one for the main power. So the Naza is connected to one of the main ones, and I'm going to redo some of these solder joints because I don't like them, but they're not cold joints, they'll hold. This isn't under a lot of stress. So, you know, I've got video transmitter hooked up to that right here, to one of the small ones. I don't like that a whole lot because it's a really small joint there, and you know, I'm just a little worried that something might get in there and short that. You know what, if it happens, the thing goes down, and it's $5 to fix it, so I'm not worried about it too much. You should put liquid rubber on these to make sure they don't ever touch each other. I'm probably going to do that later. I'm not going to do it right now. This is the main power to the Naza, so it's hooked up to positive and negative. This goes to the Naza. I'm not sure where that goes. GPS in. So, oh, this goes to the little board that makes light, I think. So this goes here. This is to tell you what mode you're in and if you have satellite lock. We've got GPS in. I am not entirely certain where this guy goes here. I'll have to figure that out. So, you know, you go in like this. I think. Let's see. Yeah, that's a 4-pronger. Not sure. Maybe I'm nuts. That's not GPS though, so I'm not sure where that goes. I'm gonna have to figure that out. But GPS goes here, like that. And this guy, I am not sure where this goes. It won't be too hard to figure out because I put this thing together about 50 times. So let's see. I'm not sure. I'll figure it out. But this is your status lights for your Naza. Tells you what mode you're in if you have GPS lock. I already said that. Anyway, I'll continue on to put the top plate on, then I'll show you where I put all this stuff. Wow, so that was a giant beatdown. Getting these screws in. So taking them, how do I say this? Taking the screws out of the arms, tops of the arms, and the bottom plate. Put the bottom plate on top so it sandwiches sucks. Took me like 20 minutes just to figure out how to do it, but everything is really solid. This thing is tough. Oops, that's got a little play in it. That ain't gonna matter. So, you know, that's just play in the screw hole. Not much I can do about that. The hole I drilled. So we'll have to see what's going on with that, but you know, looks like it's gonna work. May need to tighten these down a bit more just to see if I can get that out of there. I'm a little bit surprised I was doing that. But those are the rear legs, not that big of a deal. I'll tighten those down. So now, this being the front, we have these wires here. There's no landing legs on this or anything, so don't start worrying yet. Here are the wires that go to flight controller for the motors. Okay, this is the battery. This is hardwired into the system here. This goes into the Naza. This goes into the Naza. GPS goes in here, which I did get figured out. I took the mounting plate off the bottom. I'll sticky tape that somewhere, probably somewhere around here. Then I have to put the offsets in. So I don't know, there's not that much left to do before I go out and crash it. So I'll start putting components on here and see what I can do with it. And then I got to build the camera tray, which might be another whole other detail. So anyway, stay tuned. So had to calibrate the ESCs. These are Simon K firmware, and you need to calibrate them per your transmitter. And so you can't do that with the Naza plugged in to your receiver. So what you got to do is take each motor out of the Naza, and let's put these in better. Put it in the throttle channel, which is channel 2 on this receiver. Put your throttle at full without propellers on. Plug the battery in, you'll get a beep, beep, and then you got to go from full throttle to 0 throttle, and it'll go beep, 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 and then it's calibrated. So you got to do that for every motor. What was happening for me was I couldn't get this motor to spin up at all when I was doing the motor test in the DJI Naza-M V2 software on the computer. So I was freaked out. I thought I had a bad ESC, and I thought, well, maybe I screwed it up when I was doing the testing with the servo tester. So I went in and calibrated each of these for my receiver, and then still wouldn't work. So then I went into Naza firmware and set the startup motor speed from medium to high, and that seems to have fixed it. So now I've got all these calibrated. I verified again that they're spinning the right directions. Some other things I have to do yet. I've got to mount some of this stuff to the board. I have to set up my telemetry unit to be connected to power so I can get a voltage reading, so I know when to bring it home. I have to set up the Naza to tell it where the GPS is. It needs to know how far away the GPS is from the actual Naza unit. So I've got to measure from the Naza unit to the GPS and tell it how many centimeters it is away in whatever axis, X, Y, or Z. So right now it's not set up correctly. With that won't make it not fly, but it will make it toilet bowl in GPS loiter mode. So you don't want that, or it'll make it fly crooked. Really weird how it works. So got to mount this, got to mount that, got to mount that, got to mount that. I need to tidy up these wires with zip ties. I need to build the battery tray and camera tray, and then I'm pretty much ready to go after it's all tidied up. So it seems to be working fine. The Naza's working. I've got everything set up the way I want it to get set up. I haven't set it down and let it get a GPS lock yet, but I'm sure it will. So that's where I'm at, and I'll show you when I'm done. Okay, well, it's pretty well buttoned up. I'm a little worried that the telemetry unit will interfere with the GPS and a few other things, but you know what? We'll find out. It's pretty light. That's the status LED for the Naza. GPS mounted here. The PMU here. Telemetry, and all that does is tell me battery voltage. Telemetry is wired into the bottom right there to tell me what the battery voltage is, and then it connects into the actual receiver, the Spectrum receiver on the data port. So on my transmitter I can see at all times what my voltage is, and if it drops down below a certain level while under load, you hit the return to home and it comes home, or you fly your way home. So I don't know how this is going to work out. I have not put the landing legs on it. That's coming up. I need to tighten down a couple of these because I noticed that these rear legs are a little bit wobbly. I don't really care about that too much, but might as well see if I can get the wobble out of it. So not bad for, I don't know, started at 9:30 or 10 and it's what, 3 o'clock, so a lot of goofing around, trial and error, figuring it out, but it should be an interesting quad. I mean, it should have a crap load of power, even on 3 cells. So what's going to happen next is I'm going to put landing gear on it, which may or may not be useful at all because I'm going to have a battery tray below it. But so the battery tray and the camera tray will fit down here, and the camera will be pointed out this way, and you won't see the props in the camera. So, and here's the power for the camera, or for the transmitter. I've already got that set up. That's the one thing I need to put on yet is this. I'm thinking something like that. Don't know at this point because it may have to go up like this, since I probably should have thought of that too. Or back here, probably back here, if I can reach. So I'll have to figure that out. This is probably the last thing I'm going to mount because I don't know where my Mobius is going to be. This is the Mobius I'm going to use. Anyway, till next time. Okay, so I'm not even going to go over building this battery tray and FPV and camera tray. That was a pain in the ass, bending wires and stuff. But it works, and I got the Mobius on it, and the battery, and it's Velcroed down and strapped down. The reason you do that is because if you strap down something hard that's on Velcro, it will not let go either, because it will stick to the Velcro no matter what you do with it. Same thing for the battery. Velcro is kind of an iffy way to do stuff, but sometimes that's all you got. So if you have Velcro and that's it, make sure you strap tight to the board there. This was a pain in the butt to build, this little deal here. Decided to put the video transmitter on top. That's just double side taped on top. Oh well, falls off, falls off. Had nowhere to go here because this is a small quad. I can't go, I guess I could have gone sideways with it and pointed it out this way, but I'd rather just go traditional and do it this way, and I may find another way to mount that down. But this stuff is really hard to get off. I mean, this is not going to fall off. So it's all set up. I tested the motors. Now all I have to do is put motors on it and go maiden the damn thing, which means I'm probably going to crash it. So maybe I'll get it on film. So we'll see what happens.